With me today, I have Chip Northrup, owner, founder of LeadTech, a company developing software for virtual marksmanship simulations, targeting training on shooting moving targets. So, Chip, thanks for joining me today. Uh,
Good to be here. Thanks.
yeah. And I haven't demoed the software and would love to get my hands on and experience it at some point. But I've seen some videos and clips of its capabilities. But this will be a great learning opportunity for me to really gain insights on the solution and its capabilities. So, real quick, would you like to go in and summarize your background and what your company is providing?
Yeah, well, what about 10 years ago, I went to the skeet range to learn how to shoot skeet better. I had shot before, and I started taking lessons, and I quickly learned that a skeet instructor's ability to describe how much lead is necessary on a clay pigeon is limited. And it occurred to me that there was probably a better way to learn it, and that would be to evidence where the lead was given the ballistics and whatnot in a simulation, in a simulator. There are simulators out there, or at the time, to teach skeet clay shooting. But oddly enough, they didn't display where what the lead point was. In other words, they would simulate shooting skeet, hit it or miss it, the clay, but they didn't actually display in the simulation where to aim, if you will, or where to point in the case of a shotgun. So we filed for a patent to display that in an interactive projection system, which was prevalent at the time. And and then when VR came out, we got two patents on interactive projection. Then we got three patents on VR because it was clear that the more convenient way to do a marksmanship simulation is in VR. Patented that. And then when AR came out, when HoloLens 2 came out, then we got two more patents to display lead in an AR headset. And in the case of AR, it also anticipated tracking a live target and using AR to shoot a live target. So, so we reduced that to practice, meaning we made those concepts work, and we went to market with a VR system called Clazer and sold that on Steam as a learning game for skeet, trap, and sporting clay. And what we discovered is that in order to do this correctly, you can't do it with a mouse. You can't do it even with hand controllers unless you're in an armature. That you really need to put the tracking system on the gun. So we built a system to put a VR tracker, a Vive, on a gun, on a shotgun, on your own shotgun, so you have the sight picture of your own shotgun. You can recreate in VR, and that is the way to kinesthetically muscle memory. Learn how to hit a moving target is with your own firearm. And at that point, we were approached by a group to do a simulation for Three Gun Nation, three gun competitions, and also another group to do shotgun shooting on waterfowl, on birds, upland game birds and whatnot. And we looked into that, but at the time it occurred to me that, and others brought this out to me, that the high value usage for this was really not to shoot clay pigeons. It was military. And so about 3 years ago, I did a demo for PO Stry, ST, SVT, about a dozen people. It was remote. It was during COVID, but we actually demoed the shotgun shooting simulation. We didn't have a simulation built for military targets, and there was considerable interest in it at the time. I mean, on the call, because it's inexpensive. The ballistics are correct. It's the repetitiveness and the ability to do reps and sets on targets was built into the simulation, and it was patented, et cetera. So And then at that point we began to do demos for at Stafford for the Marines, for TCOM, and then we did for Traces in Orlando, and subsequently and coincidentally at that time, both of the Marines and their armor were moving towards moving targets at the range, namely robotic targets that were more realistic in their movements and in the presentations, angles, and whatnot than the track targets had been previously. The mannequins on tracks. So they actually had something to fulfill or to validate the simulation work at the range, something realistic. So, and that was really just coincidence. I mean, I wasn't aware of but frankly, in the process, we met Walt Yates and other people that were advocating for the use of robotic targets, which I must say are absolutely essential to this, because obviously at this, what you validates simulated skeet training easily. You've got to have some way to validate the training outside of the realm of the simulation itself. And frankly, a robotic target that's the way to do it.
Right. Interesting.
So anyway, so we started doing simulations in VR, and we didn't. This is actually sort of at the transition towards robots. So we simulated a Toyota truck because we wanted to show that not only could you teach lead at a slow speed, which is in the simulation of 15 miles an hour, which is a sprint at a robotic speed, but you could also shoot a vehicle with a cruiser weapon. So we did a 30 mile per hour target and a 60 mile an hour target, which ostensibly would simulate a drone, although it was a truck. And we demonstrated, what the ballistic lead would be on it. And to some people, it's kind of surprising, even at 15 miles an hour, how much lead is necessary, because they think that. And by the way, this is partly based on the existing simulation, marksmanship simulators, and basically all video games, is the ballistics are effectively the speed of light, particularly when it comes to lead. So in other words, if a target is moving in Onward or Call of Duty or whatever, or even if it's moving in some of the existing legacy laser shooter simulators, there is no lead evidence. So the trainee or the gamer begins to think that all they have to do is aim right at the target, and they will hit it. And of course, if lead is involved on a target, then the worst place to aim is right at the target,
Right.
because that assures you ballistically that you will hit the round will go behind the target. So, and a clay shooter or burnt wing shooter knows that. Anyway, so we were dealing with a legacy base of the mindset, of the recruit, if they're gamers, and the mindset of the people that are running the simulations, that there is no lead required. In fact, it's not that it's just not displayed in the simulation. It's not even ballistically evidenced in this situation. And there's one other, I point this out, there's one other kind of impediment, if you will, to teaching lead in the military, but it's not the case necessarily in clay shooting, is that shooting a moving target is, and Luis Velasquez basically pointed this out. It's more like a dance. I mean, it is a dance movement, because karate movement, because you got to move. You have to know how to move your upper body and whatnot to hit the target. You got to move with the target, and if it needs lead, you got to know how far in front to get of the target, and that is totally antithetical to traditional riflery marksmanship, where you're talking about holding your breath and stuff. It's like, you have to basically immobilize your body, the gun, everything. Movement is the last thing that you can countenance. So and this is the phenomenon of that, and I've seen this anecdotally at the range, is that if you take a middle-aged guy or middle-aged plus, and that has spent their lifetime shooting metal targets at the range, and you take him to the skeet range and he's never shot skeet before, I mean, they're basically unteachable. And the reason why is just because is just when someone, and this is a mental phenomena, when someone locks in on the target, a marksman, when they lock in on the target, everything slows down. Their brain slows down, their motor skills slow down, because their brain is telling him, you're on the target, stop, hold on the target. And obviously, if the target continues to move, then even if they continue to move with the target, their movement will be retarded by that training, that kinesthetic training, slowing, so that effectively the target, the lead point of the target moves on, and they miss it. They miss behind it. And I think at some point it's probably be quantifiable. They basically become untrainable. I mean, because they're going to revert to, if not freeze on the target, hold their breath, squeeze trigger. Frankly, all that's bullshit. When it comes to a moving target, wing shooting anyway, is they're going to, if they go to default to that 100%, they're going to default to some fraction of that, and that fraction is how much they're going to miss behind the target. So anyway, so we've got big challenges. We have legacy systems that have been mistraining lead for decades, and in the case of video games, continue to misrepresent it. And then we've got frankly the embodiment of this marksmanship mentality: hold breath, squeeze trigger. God bless you. At the skeet range, those are the range instructors. Those are the drill instructors, the guys that teach marksmanship at the range. And unless they're skeet shooters, they'd be challenged to hit a moving target. So we have legacy things to overcome. And then what I want to get into, if you look any questions on that, is how the difference in how the Marines have addressed this challenge and how the Army has addressed this challenge. It is night and day.
Yeah, I definitely want to
And
get into
I
that.
don't have to
Mhm.
do this with any, simplify emblazoned on my forehead. It's just, I mean, I've learned it the hard way. It's amazing how the two groups have addressed the same problem.
Yeah, I would like to get into that, but before, oh man, I've got a slew
Yeah,
of questions just based off of
right.
your insights. But
Yeah.
initially, I'd like to ask: is this a intelligent tutoring system? Is this like a virtual smart optic? If I'm
Oh yeah. Well, what it is yeah, it's what it is well, at its core, it's a methodology, a patented methodology that's reduced to a software in VR, written in Unity. It can be written in Unreal. That's applicable to 2D simulators, VR and AR. So there are the hardware necessary to implement it is all commercial hardware. So in other words, in the simplest application, the most straightforward, you would have a VR headset, and in the VR headset, not only do you simulate the target, but you also simulate the aim point in front of the target, the amount of lead necessary to hit it, and you can turn that aim point off. In other words, you can either display the lead or not display the lead.
right,
And the idea is that through practice, you begin to build up some sense of how much to lead targets at different speeds, trajectories, etc.
yeah, and
So that's
distances,
VR headset. And secondly, we talked about a little bit before the call, is that since this is a very specific muscle memory movement, meaning gun up, cheek to stock, sight picture on target, you really need the implement, the gun implement, to be as realistic in its dimensions as the gun that's going to be used in the field. And so in the clay shooting, the tracker fits on your gun. The VR tracker fits on the trigger fits on your gun, because your gun's what you're going to be using at the range, and the sight picture, cheek well, sight picture has got to be the same as it appears at the range. So hardware wise, it's a good VR headset. The higher resolution, the better. Although, and frankly, in the military demo, we use a ACOG. We simulate ACOG 4-power scope. So then that's very helpful
Yeah.
to VR resolution. I'll talk about that in a second. Um, and then we simulate, and then we're now using, or we've gone to use a Manus Blackbeard trigger. So we're basically putting an electronic trigger into an M4, and we're using electronic bolt to reset the trigger. So we're basically, and we're also still using a tracker on the end of the accessory rail. So now everything fits into as a kit, as a drop in into an M4A1 or an MCX or whatever. Because, and that's also something Manus, I asked Manus to do this a year ago. They probably already thought of it. But so they have just now come out with a Bluetooth signal. So now all of that kit is commercial, off the shelf. The Marines weapons training battalions bought about 700 of these gizmos. So with the Bluetooth signal, so now that all becomes a drop-in kit. You put it on your service rifle and you train in VR with simulation of the magnification of the scope, etc., on moving targets. Um, can do the same thing with crew serve. I'm really optimistic about grenade launchers, and we can talk about that in a minute. But so so again, but it's patented, reduced to practice software. Software can be sent out over Steam. I think that's the plan, so that basically
Okay.
anybody
Yeah.
anybody that has a license, meaning any Marine Reserve, any Army Reserve, any recruit, any active duty, any dude at an embassy or in the hulls of the ship, could practice this whenever they want to, and can download the software. And like I said, buy the kit, buy the Mantis trigger, buy the Vive headset or the
Right.
Vario headset, and practice. And one thing, and while
And
I
and
don't
that's with
forget it,
their own service weapon. So they would go
yeah,
check that
that's what
out.
their own
Yeah.
service.
They the
And
idea.
as a convenience, what we're going to do is you can also just use the hand controllers if you put them in an armature. In other words, if you put it in an armature that holds them in the
Right.
position
Mhm.
of where
To
the
simulate
grips,
the
the
rifle.
foregrip and the
Hmm.
pistol grip would be. So you could it'd be less expensive, it'd be easier to get past security. But so you use your hand controller, and so that would go out into MetaQuest, and then it becomes very inexpensive. You get a Pro Tube armature, which even you can even get a little haptic in it. And by the way, obviously in the service weapon, you can get a drop-in haptic from Green Ammo or Haptech or somebody. So, but the idea of it is that given the totality of the demographic of the market, including the reserves, is like 200,000 Marines and pushing 750,000 Army Reserve, National Guard, etc. I mean, the point is that not is that isn't this not this is not a fixed base of operation. You know, go to Pendleton every 2 years. I mean, this is
Right.
like practice it every day if you wanted to.
Right.
And this gets to a point that's critical here. This is like the perishability of this skill is like makes handgun training, like once a year. If you're in a police department, you got to go shoot once a month. And I would say to refresh the skill on moving targets, you need to do this about once a month. And I'm about 4 months out of practice myself. So that's something that you cannot, you have to be able to address that with a cost effective system.
Right. Right. Can I stop you there? I do have
Yeah.
some points of thought on your
Right. Yeah.
segment. And
Right.
so I'll give you my initial thoughts, and I'm really curious as to what your company is doing. So, um,
Okay.
I believe that we probably agree that technology is always improving, and the capabilities of hardware and software are becoming better and better. And the point
Yeah.
of that statement is that, is the term improving, which implies that it's not perfect. Otherwise, simulations would be indistinguishable from reality.
Yeah.
But a simulation is the replication of reality within the left and right lateral limits of today's technology. So you had brought up projection based VR, AR. So as far as like projection based training, the current
Yeah.
limitations are like the simulation of long range marksmanship and the pixelation
Yeah.
distortion. And then also with VR, there's this misalignment of, virtual weapons versus real weapons. And
Yeah.
the
Right.
potential
Well,
of
let
negative.
me, can we,
Yeah, yeah.
talk, those are,
Yeah, let me
let's
finish
take those
my
two things.
yeah,
Those
let
are
me
good.
finish my thought first,
Oh, okay.
if you
Right.
don't
Yeah.
mind.
Yeah.
So
Really. You're running to my bandwidth of my memory. So
oh shoot, sorry.
yeah, go
So
ahead. Right.
just real quickly with the limitations
Yeah.
of
Yeah. Yeah.
yeah,
Right.
with the limitations of projection based pixelation distortion, VR's misalignment, and the technology is improving, and I do believe it'll get there at some point.
Yeah.
And
Right.
maybe more realistically with AR or reality based training. But how is
Right.
your company dealing with these limitations for marksmanship training in a
Okay, well,
simulated
those are,
environment?
I need, if you've read what I blog,
Mhm,
snarkily on LinkedIn,
mhm.
those are really good questions because let's talk about, and the short answer is a scope. And I'll explain the difference between the two profoundly is whether or not you use iron sights. I mean, I'm talking about military, not clay shooting. Is whether or not you use an optic or iron sights. And here's why. If you use an optic, if and I'm kind of assuming we're using an optic,
Right.
either a reflex sight or an ACOG or, I know I keep doing these, this product placement for Trigicon, and the reason why is if you force the simulation, to look at the reflex or the ACOG, a magnified scope, then a whole bunch of things sort of go issues, if you will, that you brought up kind of go bye bye. One of them is you're not really worrying about the discrepancy on what that VR simulated M4 looks differs from your Coyote tan, real life M4 because you're not looking at it. You're just looking at that scope. And so your sight picture, your world is constrained to that scope or that reflex even. So that eliminates, that sort of makes not irrelevant, but mitigates any issues of the disconnect between the real world and the VR gun and your
Right.
real gun.
Right. And
To,
because
to
the
and
focus
also
is what
focus
you see
your
down the
attention
scope.
on what matters.
Hmm.
But that gets to the other point about the 2D. The problem with 2D is, and remind you that I got two 2D patents and we have built 2D simulators for clay shooting. And the reason why we didn't for military is because it has two fundamental problems. One of them is as soon as you put a telescopic scope on a rifle, by the way, 2D works great. Like, Gunfighter Jim works great for short distances, iron sights, shoot, no shoot, kill terrorists, don't shoot hostage, etc. Great. God bless you. But if you think, but the defined gap for the Marines is 50 meters to 300 meters. It's five on moving targets, meaning where they need to focus on learning. It's 500 meters at the range. So that means you're going to use a scope. You're going to use an optic. You're going to use a scope. As soon as you use a scope in a 2D simulation, then Mr. Shooter, you've got to move back away from the screen, or the scope will be out of focus. So now, and the other thing is when you've moved away, and given the size of the screen, if it's a realistic size, the pixel density on that screen, even with 4K, even with the best commercial grade projectors, is going to be a fraction of the pixel density that you would have in a Vario or an HTC Vive headset with foveated eye tracking that's sticking all the friggin' pixels right there at where you're looking at through the scope. So, so in other words, the clarity of the image in VR is going to be, much better than what it is in 2D. And those are so in a sense the watershed or the catalyst the key variable there is the ability to represent that and deal with what's in the optic.
So looking within the sites in
Yeah,
VR, what
right.
exactly am I seeing other than lead? Because then I become
Well, I mean,
dependent
you're
on,
seeing, well,
right?
yeah, like for instance,
Am I
in the
seeing
demo,
range?
right?
Am I
In the
seeing?
demo, what we did was, in the demo, we did a flyover of the New River at Lejeune to one of the ranges at Lejeune. It's on the other side of the river, from town. And so I mean, so you're at a real, you're at the representation of a real, honest to God, Marine range. And we do the same thing at Fort Moore, or Pendleton, or whatever. So it would be, you recreate the terrain of the range, the distances, whatnot. We just now did the first draft. We do a robotic target. It's kind of the RFP, is coming out soon for the Marines are, but they're all basically the same. A dummy on a Segway, hit it, it flops back. So we've recreated that as the target, and then as the training aspect of it, the aim, the lead target image, and to use the parlance of the Army doctrine, the lead image, or the lead target is represented in this demo as a day glow green mannequin. So basically, so what you see is on a full crossing target is you see the robot going across the range 200 meters, whatever. And you see the lead as being the same mannequin shape, the same torso as the target mannequin, but as a day glow green image. And that is what you shoot at. That's what you imprint on. That's what you learn on. You're shooting ahead of the target. The day glow green lead target image is what you're shooting at, and that enables you to do shot placement if you're that good on the torso, and it's et cetera, et cetera. Same thing with oblique target, going away target, coming forward
Yeah.
target.
And yeah, I mean, when I first joined the Marines, obviously beyond initial schools, we received periods of instruction on methods of tracking or ambushing targets. And I found that as I progressed through my career, every time I was on, an unknown distance range, the range with moving targets, I found myself, using a trial and error method. So I guess, my question would be, um, I'm PFC Schmuckatelli, or Officer Schmuckatelli. I'm trying to learn the science behind leading a target for
Yeah,
moving targets. The MITs out on the range. The virtual world replicates the environment. I'm seeing the lead for the specific distance, but is there a capability of learning? Am I identifying the distance of the target? Am I understanding the trajectory? What azimuth and direction? Is it left to right? And am
right,
I learning how to identify speeds of the target? And then is there the capability to remove all of the smart optics, virtual smart optics, and practice that and train to
right.
that extent?
Yeah, well, there's a here the first of all, the training, the science of it is, it can be trained. It should be trained in the classroom. It should be trained in a video. It could be, we can do that in the VR. For instance, in the VR, we have one of the features of it is that we show the speed of the target it, right over the target, a speed indicator. We also showed the range of the target, which is, we know that obviously in the simulation. So we can do that. We can show an indication of that that's literally over the target. So in other words, the robot goes by and it shows this is what 10 miles an hour looks like. That's what 12, and this is what 150 meters looks like, and this is what 300, because those indicators are shown over the target.
Right, where you could practice that the
Yeah, so
science
you
behind
get
it, what
that,
you learned
and
in the
so right,
classroom.
and so if
Right.
you had a spotter,
Hmm.
yeah, and if you had a spotter, if you had somebody that had a rangefinder on their scope, then you would begin to build some skill memory of that's what a moving target looks like at 300 yards. You've that's what and then you go to the range, I mean the field, and the spotter says that's we're at 250. Then you have some memory from the simulation training. Again, remember, we're not talking about going to 29 palms every 6 months. We're talking about doing this like a lot. Um, anyway, and the other thing is now the best way I think to learn the ballistics of this is what we do is we simulate tracers, and not only do we simulate tracers, but when you hit the robot, when you've got the lead right, you've turned the lead target image off. You've got some native ability, is just like, it's a cliche, but just like throwing a football or kicking a soccer ball, is that we show the tracers going out in slow motion. And what you see viscerally is you see the intercept point of the robot with the tracer going out here, robot coming across here, bang, intercept, and you begin to get, you see what the lead is visually, but then you understand how the time of flight of the round, which is, the 90% of this ballistically, particularly if you're 0 to, 50 and 200, then the time of flight of the round is that long. It's a fraction of a second, but the robot's still moving, and it's that long, and you see what that intercept with the virtual laser that's in the simulation, that's in the simulator. Okay, now back to your, where does this go? How does it go to the range? That's a good question. And that's also something that we're working on, is that the way this goes to the range is more or less the same way as it was in VR, because the VR headset, for obvious reasons, is more similar to the AR than the 2D. And by the way, one other thing before I forget it is you if you put the VR headset on see-through mode, then you can see the gun. You have all these gizmos on your service weapon, so you can hit see-through and you can see the gun, in the with the headset
Right.
on.
With
So
path
there's
pass
it's not
through.
like you're in La La Land. Um, okay, now back to the AR, because this is the punchline of all this. And we did this demo in Oviedo at FAC, and for PM Traces and Todd Butler, Nav Air. And so we had this meeting, and Traces, Marcus Reynolds, did the demo, and he actually hit a bunch of targets. And most anybody above like a bird colonel, they can't hit a damn thing. And they asked me, why don't you do this at ITSEC and stuff? Because I said some major would show up with his entourage, and he wouldn't hit a damn
Right.
thing, and
Right.
he just gave back.
Right.
It doesn't
You
work.
got to protect
So
that
anyway, so
image.
Reynolds he was hitting these targets
Yeah.
like, and I had the it was so indiscreet. I just asked him. I said, How did you hit those things?" And he said, "Yeah, well, I'm a deer hunter or something."
Yeah.
Because but anyway, so we get into the meeting, and he said, "Well, this is really great, Chip, but I want to see this in an optic, because obviously, when you go to the range and you shoot the robot, it would be helpful to have some indication of what the lead is on the robot at the range." And frankly, that is in fact what the two AR patents address. And that's what we've been working on now, is to display the aim point, the lead target image in the AR headset. And, fortunately, there's a guy named Teddy Kumar at Stanford Research Institute has patented the display or the use of an AR headset as an aiming device, where you natively recognize the point of aim of the weapon, and then you can pin a hologram, the lead target image, etc., as an offset to the gun. So you put the AR headset on. You see the target of the robot. You put it on the target, and the computer knows what the lead is on that target. So you display the target on the robot. And now you've taken your VR training that you've been practicing on intermittently, and you're prepared. So when you go to the range to shoot the robot, you're not just spraying lead out there. You have some sense of where to lead it, and you even have a better sense if you put the AR glasses on. So all that is, imprinted, reinforced, so that you build some native ability, some instinctive ability to hit it. Now, beyond that, the next step is you stick the lead in the scope, in a digital scope. The and but the kiss that is, of course, that involves, and we got two patents on that. But that involves actually literally electronically tracking the target itself,
Right.
get that image into the digital.
Yeah.
And that's another, that's sort of phase 10. That's
Right. That's
probably,
future
that's a crew served
implementation.
weapons.
Hmm.
That's a crew served weapons deal.
Yeah.
And that's also from just ballistically, from my standpoint, that's a grenade launcher.
Yeah.
That's an airburst grenade
Yeah,
situation.
so let's get into the training implementation. And, for
Yeah.
marksmanship training, and I won't disclose the organization or location, but I've seen local nationals train to the standards of these three-letter agencies with Western weapons using a projection-based simulator, then turn around and qualify on the live range with statistically less unks than with traditional methods. So,
Right.
applying that to the Marine Corps or the Army, do you want to get into, how this is going to implement into the training evolution and the
Yeah, well,
differences?
two things. First of all, the only study, the only uh, peer reviewed, controlled study of this was done by the Canadian military, the DRDC. It was the study that was done several years ago. It was only published last year, and what it did was that it showed that displaying a lead image, a lead point on a moving target, was efficacious. That someone learned lead quicker by seeing what the lead was, than if by trying to figure out what the lead was the hard way, which is the way, of course, most people learn how to shoot clay targets. So we know that there is, or at least we have evidence that the methodology itself is effective to accelerate the learning curve of hitting a target, which is why we're suggesting that it should be pre-training before they go to range and shoot the robots, and then as that be used as refreshment training to be validated on robots. So now where they are is this: the the next generation marksmanship shooting training contract was awarded to Canadian Aerospace / FAC Milo like a year ago, I guess, almost. And it was, and in the bid, FAC Milo referenced the LeadTech methodology. However, the spec was this is basically going to end up, it's PO Strive, but then it ends up SVT runs it. It's their WSD. It's their 2D laser shooter marksmanship simulator. So anyway, so we got to this. So the spec was, though, the spec on movers was derivative of the range manual, the 2016-2018 Army range manual. And so, we looked and we've talked to Maneuver Center of Excellence. We've talked to Embry School about that, who wrote the spec. for this contract that FAC has to meet. And, FAC could, well, anyway. So what, what we found was, and I actually wrote a blog on this, is that in the range manual that is literally, if you will, dictating how moving target engagements have to be addressed in a simulator, built by FAC, that they've completely misrepresented how lead is calculated, and in the spec it's calculated wrong, and in the description of the methodology it's wrong. And I wrote like I said, I wrote a blog about it. They, for instance, say all the spec basically has all the specs are based on orthogonal or perpendicular moving targets along the x-axis. They didn't actually describe any oblique targets, but in the spec, it's driving this simulator design for your PO stride. Is they say that, for instance, that on an oblique target, the lead on an oblique target, a 45-degree oblique to say a 90-degree perpendicular, is one half of the lead, given the same speed and distance as a perpendicular moving target. Well, guess what? It's not. It's not half the lead. It's actually the sine of 45 degrees, which is 71, and the somewhere along the line. So, and I wrote, is this is literally, it's pre trigonometry. It's actually pre Pythagorean. So they're like 2,500 years. They're like early Bronze Age math wrong on the Army range manual spec on moving targets, oblique targets. So it's like, and I published that, and so somebody that knew the history of the range manual found that the range manual, the 2016-2018 version, that are the gospel, the Deuteronomy of this new simulator, were actually the range manual actually correct in 1980, and somewhere along the line between 1980 and 2016, 2018, somebody basically forgot 2,500 years worth of science of geometry, because in other words, the 1980 era range manual did in fact indicate that the correct lead. Again, we're talking about formalized setting mannequins on a tracked moving target, but it is in fact the sign of the angle of the attack that you're shooting at. So they knew that in 1980, and somewhere whoever wrote the 2016-2018 manual, that is the gospel of the Army's new simulator contract, forgot it. And so FAC, God bless them, Mile and CAE bid against this pre-Pythagorean spec on moving target. So the long story short is, unless maneuver center of excellence, infrastructural, PO stride, ST, get this right, get some understanding as to how to display lead correctly on a moving target, I'm not sure where that. I don't know. I really don't know where that's going. And the other thing, of course, is it's a 2D simulator. So basically, forget a telescopic scope. The spec goes out to 500 meters. And by the way, the lead on a crossing target at 500 meters is 15 feet, which is like, God bless you to try and hit that damn thing. But anyway, so I don't know where that is, frankly.
Yeah. So how's that compared to like PM Traces and the Marine Corps?
Okay, now to the Marines. Okay, so the Marines, they have range manuals too,
Mm-hmm.
but you know what? God bless them. They actually want to hit the effing target.
I'm
It's
biased.
like,
I would agree with that.
it's like, to hell with the range manual. Just hit the damn target. Okay, so here's how the Marines are going about it. Much more enlightened, if you will. First of all, unfortunately, they're burdened with a 2D simulator. The newest thing, the ASOL simulator is, is a 2D simulator, which will be great out to 100 meters, maybe. I mean, certainly in like what it was built for. Shoot, don't shoot, hostage crisis, that all that bullshit. So, but they know and they admit and they say we are going. I won't tell you who, but it's PM Traces. We are going to VR. We get it. We're going to VR and we're going to AR on marksmanship simulations. The 2D simulators that we're seeing now, even the brand new ones, I pray that they are, and I believe that they are the last generation of the 2D marksmanship simulators, that they will be supplanted, that they will be replaced with VR and AR. Okay, so now how are they going about it? All right. Well, first of all, what they did was, and this is the trick about the Marines. The Marines don't have any money, but they're owned by somebody that does. And so whenever they really need a big problem to be solved, they just pick up the phone and they call the Navy. And God bless them, there's people at the Navy that help the Marines on these matters, and they're really, really smart guys. So what they did is they said, and they read my blogs or whatever, my screeds, to TCOM, and they said, God, we didn't know that none of our simulators evidenced lead. And we're going to find out, they're going to check, your allegations to see if check that. So what they did is that Office of Naval Research hired Joe Hamilton's crew, Buchanan and Huffman, to basically go out and look at their existing legacy simulators and see how they address lead. And the short answer is they don't. Not riverine, not amphibious, not nothing. They don't address lead. So they're going to address that. And then secondly, they're going to try and determine what the best way to teach lead. Possibly with the legacy systems, which need it a lot, particularly the gunnery simulators, and also the marksmanship sim, and definitely for the next generation. So they're scientifically studying that now. They should be done by modern day Marine or by the summer, as to how the hell to actually do this properly. And they realize that none of this stuff is in the manual. What is in the manual, and back to what your experience was, is I would say is an overly formalized way with a scope that's got a MILRAD marks on its x-axis. If the range instructor tells you that's, he says, well, he doesn't even maybe tell you this, but he'll say it's, known distance, 200 meters. The thing, the mannequin is moving sideways at 12 miles per hour at a constant speed. And that's X number of mil offset POA, and that's what your lead is. And bang, you hit the damn thing. Because in an overly formalized setting, with the lead being evidenced on the reticle of the scope, then you can hit the moving target. And then of course you take that, and all that goes kablooey if it's a robot at an unknown range, much less if it's in combat. And remember, lethality is a function of basically accuracy divided by speed. And, so you just, and with a mover, you don't have any time at all. Right. If they're moving between barricades, you don't have time to line it up with the reticle and figure out how many, marks it is off center. It's like, no. You have to have some native ability, some instinctive ability, like the thing was a damn rabbit. Right. You had to there's rabbit, get in front of rabbit, shoot rabbit.
Right. Yeah. And I remember, guessing myself. And, when I was on the range with unknown distances and movers, and it was almost it was almost like artillery, where I'm just trying to, adjust and walk my rounds closer and closer to.
Oh, well, no, that's it. Yeah. By the way, you said the magic word. Mm-hmm. In gunnery, in the gunnery simulators, like combat convoy simulator, that's basically what they end up doing. As they say, just you just walk, you're using tracers and you just walk the tracers into the target. I mean, it works, but
Right.
it's
Yeah,
inefficient,
how
and
efficient is it?
it's requires you to use tracers which have issues of their own.
Yeah.
That's the nutshell. The Marines are, I am convinced that they are going to get this right.
Mm-hmm.
It may take them a while. I'm going to do everything I can to help them.
Mm-hmm.
I think they're going to get this right. I
Yeah.
don't. God bless the Army. I don't know. I have no clue what's going to happen there.
Interesting. So could
It
you,
may be the next generation of marksmanship training.
yeah, could you go into some of your end users and their experiences from, the entirety of the training evolution to implementation on the live fire range?
Well, yeah, I mean the only data we have on that is the shotgun shooters. And since we haven't never done a double blind control group test of shotgun shooters, it's all anecdotal. It's like, I used it and it's great. The leads look good, etc. And I don't mean to be cavalier about it, but to get to, and we've proposed to do this with the Marines in particular, is to do the Marines have an infinite supply of control groups. To mathematically or statistically, you need like on the order of 20 to get a meaningful result. But all that you have, well, you get 20 in one control group. You take them to the range. You don't give them any, or you give them the kind of training you got on a mover, and here's your rounds, and God bless you. And the other one, you give them simulation training and see what effect it would be.
Hmm. Are there
Um,
future plans to conduct this study?
yeah, I think. Well, I mean, we made a proposal to do that. The thing there, remember, this has been studied by the Canadian Army. The Canadian Army study, and I know the author of the study is that, and this is all getting into the nitty gritty, but Office of Naval Research that Joe Hamilton's crew was working for, they read the study. One of them, Huffman, is a Canadian, the PhD, and he was unimpressed by the academic rigors of the study itself. It was kind of apples and oranges. But for better or for worse, it's the only study that I know of for military targets displaying lead in a simulator that's representative of what we're trying to do. So what we proposed is we would do, well, first of all, we discussed that we would do that, but frankly, I don't, and we looked into that, but I don't think we could do it because, for one thing, if I did the study, that no one would ever believe it. And on the one hand, and secondly, the peer group would have to be um, Marine recruits. I mean, the 100% accurate cohorts
Right,
would have to
right.
be
Your actual
Marines,
end
either
users.
recruits or trainees.
Hmm.
And I don't have access to 40 Marine trainees, et cetera, et cetera. So anyway, so they really need to do that study, and we'd be happy to help facilitate it. But
Right, right.
yeah. So, but I think inevitably that's going to happen. In the meantime, while we're waiting for these legacy 2D simulations to sort of be burn out, if you will, is that what we're going to probably do is take the specs off of the robotic target RFP, meaning the trajectory, the known, unknown distance, whatever, and just recreate it in a simulator. Just build a simulator that uses the same specs as on the robotic targets, use the same ballistics, and basically just build a simulator ourselves. Say, here it is. This is, you get a Mattis trigger, you get a haptic kit, this that, and go right back to weapons training battalion, traces and whatnot. Say, here it is, go for it.
Yeah, and part of that being obviously the future vision, by quantifying and peer reviewing the studies. Um, you know, what is your vision of the future of lead tech, and really how are you leveraging, obviously with Steam and off the shelf hardware? leveraging the wearable tech to bring your product to a wide end user
Yeah.
base.
Well, what I think what we're like what I said was is that we're going to build a commercial system based on shooting military rifles at robotic targets, and with using systems that would the ones we just mentioned that would be either programs of record or where there would be something that weapons training battalion or infantry school would buy or have bought. So it built on that system for basically anybody, preferably for recruits, reserves, Marines, National Guard, etc. That so we're going to build a system like that. We're going to use the newest generation of VR headsets and trackers will take a bit of a haptic shock. Previous generations wouldn't. So we're going to build the simplest system we can, the least expensive system we can, probably bundled if someone wants it that way, and sell it directly. And then the second thing is we'll do as a inexpensive, probably a MetaQuest with hand controllers and an armature, a Pro Tube armature. That's a very inexpensive way to do the same thing, where we're just recreating the dimensions of the gun, not the weight, etc. And so that's the least expensive version of it. Again, military targets, robotic targets, the same thing they're going to end up shooting at the range. And then the last thing is we're going to go back to Claser, which is in need of an update. And we're talking to one clay shooting simulation company that doesn't display lead, but it's a very popular clay shooting VR system for MetaQuest. We're talking about we're going to probably license Claser display of lead to them, and then we'll go back to our own system and bring it up to date. So we'll have we brought up the clay shooting aspect of it, and we'll have a military um, trainer available. And frankly, the idea about the military trainer is that it is going to be so inexpensive and so convenient to use that this is the taking out of Mattis's playbook. There's no need, there would be no need for traces to go through an elaborate RFI, RFP, et cetera. They just say, the weapons training managers say, go buy this. It's as good as it's going to get. God bless you. And show up on Monday, shoot robots.
Right, right.
In other words, so, um, and I frankly, we have it's just important, Jared. With this technology, we don't have to have a fixed base of operation, expensive projection system, a custom made, air compressor train, blah, blah. We don't have to do that. We're beyond, we collectively are beyond that. We can do a better system, better for, under $2,000, and anybody can use it. And if we can do that, we know then by golly, we should just do it. We shouldn't, I don't mean to disparage anybody. We shouldn't wait for BAE or CAE or Raytheon or somebody to solve the problem that we know we can solve for anybody that wants to learn how to hit a mover.
Interesting. So,
So,
if an agency or organization is interested in more information or even possibly a demo, how could they get a hold of you for this
well, they just go to
information?
the LeadTech. They got to find me on LinkedIn.
Hmm.
I hate to be a snob, but I think I'm talking to everybody I need to talk to. And the really about the valley of death in terms of innovation. That the ideas here, ethic, the realization is over there, and in between is the valley of death. To their eminent credit, the Marines have a whole cadre of people that bridge that gap. And I'm not talking about, the SMEs or something. I'm talking about the generals, the majors, the colonels. The guys that need to bridge that gap are there. And they know who they are. And is if you can get their attention, then you can get something done. But the point is they're not non-existent. There is a footbridge, a rickety footbridge across the valley of death.
Chip, it's been a pleasure, and I would love to get my hands on the software. To put out my own personal review.
We'll get it done.
Yeah,
It's on me to get that to you.
right. I'll put the pressure on you.
Thanks.
But it's been a pleasure. Thank you.
Thank you, Jared. Cheers.
Cheers.